We are at video 4 of our series on naming organic compound as required in the NCS CAPS document for grade 12. In this video, we are going to look at the next two homologous series, namely the carboxylic acids and the esters. Up till now, you should be able to identify alkanes, alkenes, alkynes, haloalkanes, alcohols, ketones and aldehydes. I hope as I slowly listed all of these, you are able to think of their functional groups in your mind. If you still struggle with this, make sure you go back and truly memorize that. How does the functional group look? And how does each of these compounds end so that you are able to identify them? In our previous video, we looked at the difference between aldehydes and ketones. We saw that both of them contained a double bond O, but in the case of the aldehydes, the double bond O would be at the end of the chain. In the case of the ketones, the double bond O would be in the middle of the chain. Carboxylic acids and esters also have some familiar and some similar properties. Well, if you look at the structure of the functional groups, you can see in the carboxylic acids I have a double bond O attached to an OH, which, by the way, will also always be at the end of the chain. In the ester, I have the double bond O attached to the carbon, which is also attached to the oxygen, the same as with the carboxylic acid. But this, instead of being attached to the H, as in the case of the carboxylic acid, it will actually be attached to another carbon chain. In the esters, I actually have two different carbon chains connected with an O. This is my functional group of my esters, and this is the carboxylic acid's functional group. These are the structures that is going to help us to identify to which homologous series a compound belongs. In the carboxylic acid, the functional group will always be at the end of the chain. In the ester, the functional group will be in the middle of two different carbon chains. Carboxylic acid ends with enoic acid. Examples of this include ethanoic acid, butanoic acid, and so on. In an ester, we have two different carbon chains, and we will spend another video in really focusing on how to name the esters. But for now, just as an example, names will include methyl ethanoate or butyl propanoate, and so on. Okay, so let's look at a few examples. Of the carboxylic acid, can you see there's my functional group at the end of this chain? I've got the carbon connected with a double bond O and an OH to the side. The name of this carboxylic acid is going to be butanoic acid. The noic acid is the way in which you identify that this is actually part of the homologous series, the carboxylic acids. As we said before, an ester contains of two separate carbon chains. To make it easier for us to understand and to see this, I colored these two carbon chains two different colors. But well, before we get there, let's identify the functional group of the ester. Can you see there is my functional group, double bond C connected to an O connected to an C. So this part of the compound shows me that I'm dealing with an ester. As you can see, I have two different carbon chains. One of them is connected to the double bond O, and the other one is only connected to hydrogens. The part of the chain that only contains carbons and hydrogens will end in "il" in its name, and the other part that is connected to the double bond will end in anoate. So if we put this together in naming this compound, it will have the name ethyl propanoate. We'll get to how to get to these two parts in the next video. But for now, it is just important that you are able to identify an ester when you give the structure, and to identify to which homologous series something belongs if I give you the name. Let's look at these examples. What are they? Well, if we look at this carbon chain, there's only one carbon in there. At the end of this carbon chain, it's connected to a double bond O and an OH. This is the functional group of a carboxylic acid. So we know that this one will have to end in oic acid. And the name of this compound, indeed, is methanoic acid. If we look at the second one over here, our carbon chain consists of 2 carbons. And on our last carbon, again at the end of the chain, I have my double bond O, OH, telling me this is a carboxylic acid, ethanoic acid. Last example of a carboxylic acid I'm going to show here is this one. Functional group again at the very end, and the name of this carboxylic acid is butanoic acid. Let's look at examples of the esters. How do we identify the esters? When we look at the functional group, we see that this is this double bond O connected to the carbon, connected to the oxygen, connected to a second carbon. We also know that the esters consist of 2 carbon chains. One of the carbon chains, this one over here, is connected to a double bond O. The other one is not. The one that is connected to the double bond O will indicate the last part of the name. The part of the carbon chain that does not have a double bond O will give me an indication of the first part. The name of this ester over here, ethyl propanoate. Let's look at this ester. There is my functional group, double bond O, O, connected to a C. It also has 2 chains, although chain is difficult to use a word when you only have 1 carbon. But you can see on this side of the oxygen, I have 1 carbon, and on that side of the oxygen, I've got 2. This part of the chain will give me the last part of my name because it's got my double bond O connected to it. So the name for this ester will be ethyl methanoate. Another example. Here is my functional group, the double bond O, C connected to the O connected to the C. This part of the chain will form my last part of my name because the double bond O is connected to this carbon chain. This part will form the first part of my name. So this name of this ester is going to be methyl ethanoate. Okay, let's see if you are able to identify any homologous series if I give you a structure. Remember, you don't have to identify the entire name at the beginning, so don't get frightened by that. At this stage, you only look at the last part of the name in order to identify the homologous series when you're given the name. And you also only look at the functional group inside the structure if I give you the structure in order to identify the homologous series. Good luck with this quiz. As soon as you have this done, you can continue to the next video.